Next, since I'm avoiding G for now, let's think about H. And what I'm going to do here is I'm going to kind of just dash in the other points here because in the matrix, I'm going to add these points. And this is 5, and this is 6. Okay, and what's useful about this is that in order to solve for H by itself without thinking about G, I need to rotate around a point where G isn't going to be a factor in the moment. So 0.5, even though it's not on my cut side of the truss, I can still use it because it exists. And the sum of the moments around any point must be 0 for this truss to be stable. So I can say 5, and 5 is useful because G touches 5, but H does not touch 5. So that means that G is going to be 0 moment around 5, but H is going to be something I can solve for it. So I'm going to say sum of the moments around 5, counterclockwise is positive, it's equal to 0, equal to, well, I know there's going to be H. I can say it's equal to H. And once again, I'm just going to assume H is positive and say H is creating a positive moment, again, which is means a counterclockwise rotation. I'm just going to assume that for now. H times, and then the distance away from 5. Well, perpendicularly, if I were to extend H, it would intersect with 6. And then 6 is, yeah. So I can say the distance would be the distance from 6 to 5, which is going to be 5 feet. So H times 5 feet. And then what else should I use? Well, should I use G? No, because like we said, it's touching 0.5. Should I use F? No, because it's touching 0.5. Should I use E? No, because it's not being cut, and I shouldn't use any of the other members that aren't being cut. Should I use this 2 kips? Yes, because it is an external force and it has a distance away from joint 5. So I'm going to say plus 2 kips. And I can say plus 2 kips. It's a positive moment because it's creating a counterclockwise rotation around 5. So I could say plus 2 kips times, and the distance is going to be the same as the distance from 3 to 5, which is 5 feet. So times 5 feet. Plus, okay, there's another 2 kips. It's going in the same direction, so that's going to be positive. So plus 2 kips, except the distance here is longer. It's going to be the same as the distance from point 1 to point 5, which is 5 plus 5 is 10 feet. And let's see what else there is. Well, there's this reaction force, RA. So I can say plus RA. But actually, I'm going to say negative RA because around joint 5, it's creating a clockwise rotation. So I'm going to say negative RA times, let's think about the distance. Well, if I extend RA, it will intersect joint 1. And then if I were to go 90 degrees from that, I get to joint 5. So I know the distance is going to be the same as the distance from joint 1 to joint 5. So just like that previous 2 kips, it's going to be 10 feet. Okay. So now I believe that's going to be it. And I can start solving for H. 0 is equal to H times 5 feet plus 10K feet plus 20K feet plus, well, RA is 3.33 kips. I'm going to say actually minus 3.33 kips times 3.33 kips times 10 is going to be, say, minus 33.3 feet. Okay. 0 is equal to H times 5 feet. And then 10 kips plus 20 kips is 30 kips. 30 kips minus 33.3 kips. That's going to be negative 3.3 kips. I move this over and say that 3.3 kips is equal to h times 5 feet. Divide by 5 feet, divide by 5 feet. I'm going to say h is going to be equal to 3.3 kip feet divided by 5 feet is equal to 0.66 kips. And then let's think about direction. Well, I assumed that h was positive, and my answer was positive, so that assumption must have been correct. And if h is positive, that means it's creating a, if the moment around that h is creating is positive, it means that h must be creating a counterclockwise rotation around going at joint 5. So counterclockwise like looks like this. So h, the arrow for h must be like this. Okay. So that if h is pointed away from the point, that means it's in tension.